Hi viewers, in today's video we'll be finding the derivative of the following functions. The first one being y is equals square root of x squared plus 1 over x, and the second one being y is equals x squared minus 1 raised to power 3 over 2, and it's the product of x squared minus 4 raised to power 1 over 2. Starting with the first one, which is y is equals square root x squared plus 1 over x. You all know that this is in the form y is equals u over v, which is what? The quotient rule. We let our u to be root of x squared plus 1 and we let our v to be x. So we say let u is equals square root of x squared plus 1. Then if this is our u, our du dx is what? Because we have to differentiate. Du dx is going to be, normally this can be written as, let's write it here, x squared plus 1 raised to power 1 over 2. So the derivative of this is going to be 1 over 2, open bracket, x squared plus 1 raised to power half minus 1, which is going to be minus half, times the derivative of the inside, which is 2x. So all in all, I'm going to have these two, we cancel the 2 that I have here, which is going to be x over square root of x squared plus 1, because this minus, when it comes down, it becomes positive, and we said anything raised to power half is same thing as square root of that. So this is our our du dx. So the next thing is, how about our v? V is equals x, and we all know that the v dx is equals what? 1, because the derivative of just a single variable is 1. So we have our u, du, we have v and dv. And what's the formula for the quotient rule? It says dy dx is equals v du dx minus u dv dx, everything over v squared. So the only thing we need to do now is just to substitute everything we got in the formula. So our dy dx is equals, what is v? We said v is x. So we have our x times what is du dx? We said du dx is x over square root of x squared plus 1. So I have x over square root of x squared plus 1. This is minus, what is u? We said u is square root of x squared plus 1. So I'll be having square root of x squared plus 1 times, what is our dv? dv is just 1. So I'll put times 1. Everything over v squared. So what is v? We said v is x. So we have x squared. So we have dy over dx. We just have to simplify things down here. When we have x times x over something, is going to be x squared over square root of x squared plus 1 minus square root of x squared plus 1. Everything over x squared. Now there's something we can do for the numerator here. I have, this is something as saying over 1. So what's the LCM of square root of x squared plus 1 and 1? The LCM is going to be just square root of x squared plus 1. So my dy dx is equals the LCM of the numerator. I'm trying to simplify it. I'm going to have square root of x squared plus 1. I'll make a line because square root of x squared plus 1 into square root of x squared plus 1, that's going to be 1. Then 1 times x squared, that's going to be x squared. I have a minus 1 into square root of x squared plus 1, that's square root of x squared plus 1, times square root of x squared plus 1, that's just going to be what is inside, which is what? We have to open a bracket, x squared plus 1, close bracket. Now from this point, we can expand the bracket here. So I'm having dy dx is equals, we have x squared minus, I have to affect this, I'll be having x squared, then minus, the minus have to affect even the one that is inside. I'm having minus 1 over the LCM, which is square root of x squared plus 1. Sorry, there's something I forgot to put here. This is over x squared because we had it here. So now our dy dx is equals x squared, we cancel x squared. This is still over x squared. So I'm left with minus 1 over square root of x squared plus 1 over x squared. Now let's simplify this down. This is something as saying this is equals minus 1 over square root of x squared plus 1 times, I'm taking the reciprocal of x squared, which is 1 over x squared. And we can actually just stop here. And this is the derivative of y is equal to square root of x squared plus 1 over x. So as for the second one, looking at this very well, you all know that this is product rule. The first one being quotient, the second one being product. So how do we solve this? Let's see if we can manage this space. Y is equals, we have x squared minus 1 raised to power 3 over 2 times I have x squared minus 4 raised to power 1 over 2. Looking at this, we know that our u is going to be the first part, which is open bracket x squared minus 1 raised to power 3 over 2. Then our du dx is going to be, bring down the power, which is 3 over 2, multiplied by the function itself, which is x squared minus 1. Then remove 1 from the power. How do we do that? 3 over 2. Look at the simple fraction. 3 over 2 minus 1, because I'm to remove 1 from the power. 3 over 2 minus 1 is same thing as saying this place 3 over 3, which is going to be 3 minus 3. That's going to be what? Sorry. I said minus 1. This should be 2 over 2. Because the LCM here is 2. So 3 minus 2, that's 1 over just 2. So we have half. So this part is going to be 1 over 2, then times derivative of the inside, which is 2x. I'm doing the same thing I did for this part. So I'll be having my du dx is equals 2 here, we cancel the 2 I have here. So I'll be left with 3x, open bracket, x squared minus 1 raised to power 1 over 2. So how about our v? Since we said the first part is our u, the second part will be our v. So we have v is equals open bracket x squared minus 4 raised to power 1 over 2. Same method to get dv dx. Our dv dx is equals, bring down the power, which is 1 over 2, open bracket, bring back the function x squared minus 4 raised to power, remove 1 from half, we are going to have a minus half. Then multiply by the derivative of the inside, which is what? 2x. So all in all, our dv dx is equals 2 here, we cancel 2 as usual. I'll be left with what? X over, because this thing, when it comes down, it becomes positive. This is going to be square root of x squared minus 4 only. Because when negative number comes down, it becomes positive. So I'm having, and anything raised to power half is simply a square root of that very thing. So I have my dv dx to be this. So since we said this product rule, what's the formula for the product rule? That's dy dx is equals, this is u dv dx plus v du dx. So let's substitute everything in the formula. I'm going to have dy dx is equals, what is u? We said u was this. So u is going to be, sorry, I'm going to mix colors. So our u, we said, is x squared minus 1 raised to power 3 over 2. Then multiplied by dv dx. What do we say is dv dx? I've not simplified, or say we said this. This is our dv dx, which is x over square root of x squared minus 4. And this is plus, I have v du. What is v? We said v is this. So our v is x squared minus 4 raised to power 1 over 2 times, what is du dx? Our du dx is 3x times, I have x squared minus 1 raised to power 1 over 2. So we've already substituted everything we need. The only thing we need to do now is to just clear things up. So our dy over dx is equals x times x squared minus 1, and all of this is going to be x, open bracket, x squared minus 1 raised to power 3 over 2 over square root of x squared minus 4. And this is plus, the whole of this is just to say 3x 3x open bracket x squared minus 4 1 over 2. I'm having x squared minus 1 raised to power 1 over 2. There's something we can still do here, but to avoid stress, we can just stop here. But if not, we can. You see, this is raised to power half. This is raised to power half. We can actually combine them in one square root. And same thing with this. I'm having this and this. But let's just leave it for the sake of now. In the next videos, we know how to simplify fractions in this form. Thank you.